Alright, this video is filmed in front of a live studio audience. I still want that in there. Okay? Alright, so we already went through what electrochemistry is, oxidation numbers, those are just definitions. I don't need to spend time. So if nitrogen gets all of the electrons from hydrogen that were originally in the bonds, and you'll see that on the notes that you'll print out, the nitrogen has 8 electrons where normally it only has 5, so it has 3 extra. So that makes nitrogen 3 negative, and each hydrogen 1 positive. And that's how we normally write charges, but since they're only pretend charges, instead of writing 3 negative, we write -3, because that's how you know the difference. Okay, so here's some rules for oxidation numbers, and since you guys aren't writing them down and you can print them off later, I'm not going to spend time on them. I'll do a couple examples. But if I look at NaCl and I want to know what are the oxidation numbers, I would go with rule number 3 for Na. It's a group 1. Na is a group 1A metal, and so I know it's +1. And then I would look at Cl. Cl doesn't have a rule. If you read through, there's nothing about Cl. There's nothing about 7As. But oxidation numbers have to add to 0. That's rule number 5. That's a really important rule. So if Na is +1 and Cl then has to be -1, because +1 and -1 add to 0. For example, iron is in its uncombined state here, so it has 0. If I look at number 8, nitrogen doesn't have a rule. Oxygen is -2 in most compounds, so that's -2. So here, because it's in a polyatomic ion, so for rule number 6, it has to add to -1. There are 3 oxygens. 3 times -2 is -6, so if I have to add to -1, then nitrogen has to be +5, because 5 minus 6 is -1. I don't know why we're doing that. Okay. Alright, so that's determining oxidation numbers. Once you know how to determine oxidation numbers, then you can, with electrochemistry, the important thing is gaining and losing electrons and what to call that. So we have terms. Oxidation is atoms losing electrons, and reduction is atoms gaining electrons. And some of you are probably thinking, that's the stupidest thing I've ever heard. It's called reduction, but you're gaining something. They're old terms. Oxidation just literally used to mean just adding oxygen to something. Reduction meant starting with a metallic ore and turning it into its metal, where it would be reduced because the original ore would say weigh like 100 pounds, but you'd only get like 40 pounds of metal off it. So it's an old term, and they're there from long before when anybody knew what electrons were. Those of you who like mnemonic devices, Leo the Lion says GR, so losing electrons is oxidation, and GR, gaining electrons, is reduction. So if that's the way you like to remember it, go for it. I always remember it that it's backwards, reduction gains. Okay, agents, this does come up sometimes. I hate the fact that chemists have this, but oxidizing agents are things that oxidize other things, so they themselves are reduced. And reducing agents are things that reduce something else, so they themselves are oxidized. So for example, bleach is an oxidizing agent. Whenever you use bleach on something, the bleach molecule is reduced. Okay? I don't use those terms, I try to stay with it. Okay. So if we want to look at what has been oxidized and what's been reduced in this, the first thing you have to do is determine the oxidation state of each species. Copper has a 2+ charge. Since it's a monatomic ion, its oxidation number is +2.
This is Mr. Erler, your K6 principal. We have secured the building and will not.
I don't think this has a pause.
Stage 1 clearance. Students that have secured themselves in bathrooms and other areas outside the supervised classroom, please report to the high school office at this time. High school teachers, please take attendance by reporting missing students to the high school secretary and the high school principal via email. Elementary teachers, please report your attendance by email to Joy and Mr. Erler. For those that are without internet access, please call in your attendance to the activities secretary at extension 7777. This is Mr. Erler, your K6 principal. We have secured the building and will now proceed with stage 1 clearance. Students that have secured themselves in bathrooms or other areas outside the supervised classroom, please report to the high school office at this time. High school teachers, please take attendance and
Maybe
report
he does if
missing
it's a
students
real one.
to the high school secretary and high school principal via email. Elementary teachers, please report your attendance by email to the elementary
So now I
secretary
have
and
video
elementary
evidence that I
principal.
didn't do this
For
right.
those that are without internet access, please call your attendance to the activity secretary at extension 7777.
Alright, so how do we get from copper, since it's by itself over here, has a 0 oxidation number, how do you get from +2 to 0? You have to gain 2 electrons, because electrons are negative. And how do you get from 0 to 3? You lose 3 electrons, because again, electrons are negative. Losing them makes you go up in oxidation. Okay, so if copper gained electrons, that means copper was reduced. And if iron lost electrons, that means iron is oxidized. Okay, now that one was pretty easy because the oxidation numbers were really apparent. When I look at one like this, it takes a little bit longer because, especially until you get good at oxidation numbers, okay, to be able to figure out what's all happening here. So for oxidation states, I look at, okay, I don't have a rule for copper, and I actually don't have a rule for sulfur either. So then I have to look at what ions is it made out of. Well, copper can be +1 or +2, but sulfur can only be minus, it can only be 2 minus, so its oxidation is -2, which means copper is +2. Hydrogen is +1, oxygen is -2. So now if I take -2 times 3, that's -6. And then if that's +1, then this must be +5. So 1 plus 5 is 6, minus 2 is 0, so that all works out. This copper will still end up being +2. This oxygen is -2. But to make the sulfur work out, it has to be +6, and you can check my math later. This nitrogen has to be +2, this oxygen's -2, +1, -2. Try those out on your own sometime. We can see that sulfur went from +2 to +6, and nitrogen went from +5 to +2. Okay, so that means sulfur went up in oxidation number, so oxidized, and nitrogen went down in oxidation number, so it was reduced. Okay. Redox reactions can be very tricky to balance, and so there's some steps to doing that are listed here. Again, I don't need to read them off. You can read them off on your own when you're watching the video. Just pause it, read them, or write them down, rewrite them down in your own words or whatever you want to do. Okay. So, but we're going to have those there, and we're going to use them to balance this reaction. Okay. So the first thing I need to do is find the oxidation numbers of everything. Sulfur is 0. Hydrogen +1. Nitrogen is like before, is +5. Oxygen's -2. This sulfur would be +4. This one's -2. +2, -2, +1, -2. Okay? So I look at what changed then. Sulfur changed from 0 to +4, which means it's oxidized. So I'm going to keep track of sulfur here. Sulfur is the one that was oxidized. It went from sulfur to SO2. Okay? And to make that change, it had to give off 4 electrons. The other thing that changed was nitrogen. Nitrogen went from +5 to +2. So it started as HNO3, so I'm pulling down not just the nitrogen, but everything that comes along with the nitrogen from that reaction there. And it's becoming an O. Okay? And then to get from +5 to +2, I have to gain 3 electrons. Okay, so now I've done the oxidation number, I figured out what was changing, I've done what's considered the half cell or started them, but now I have to do my individual balancing. So to individual balance, I look at, well, okay, I have one sulfur here, one sulfur there, that's balanced, but here I have 2 oxygens on the other side, I have no oxygens whatsoever. And that's kind of a new problem in balancing. So what we can do is we can say, well, where could some oxygens have been? And they could have been, since this reaction is done in water, water always has water there where oxygens could have come from. It could have had some OH minuses around that oxygens could have come from. It could have had some H3O pluses around. I'm just going to say, I'm just going to pick water, okay, because I have no reason to suspect something else. I'm going to write H2O. And because there's 2 oxygens, I need to have 2 H2Os, okay? Now the problem is I have 2 H2Os, and now I've added in 4 hydrogens that weren't there before. So there must be some H pluses now that need a home. Okay, and so I'm going to have those H pluses there. Same thing on this next one. I've got HNO3, so the N, one N on each side, that's fine. But I have an H here that has nowhere to be on the other side, and I do want water to be on this side, so I'm just going to add some H2Os here. And because I'm missing 2 oxygens, because there's 3 O's here and only 1 O on the other side, I need to have 2 water molecules come in. And that means I've got some H pluses that are missing because I only have 1 H on this side, and on this side I have 4. So I have to have 3 H pluses on that side. Now I've got all the individual things balanced. Now I need to balance the electrons. My first reaction is losing 4 electrons. My second reaction is only taking in 3. Okay? So I have to get that to balance. If I take and multiply this whole thing by 3 and this whole thing by 4, now I'm losing and gaining 12. And that's fine because I can lose the same amount I gained. Okay? Now I can add them together. So now instead of having, I'm going to run out of room. I'm running out of time. Instead of 2 H2Os, now here I have 6 H2Os plus 3 sulfurs goes to 3 SO2s plus 12 electrons. And in the other one, I have 12 H pluses plus 4 HNO3s plus 12 electrons goes to 4 NOs plus 8 H2Os. Now I can cancel out things like I can say, okay, well I've got 12 electrons here, 12 electrons there. That goes away. I've got 6 waters that cancel all but 2 of these, so I'm left with 2 waters here. And I do have some H pluses that didn't go away. And those should have just been there in the first place. And then I can add the 2 reactions together. So I'll have, when I'm done, my 12 H pluses plus 3 sulfurs plus 4 nitric acids goes to 3 SO2s, 4 NOs, and then my 2 waters that didn't go away. Okay? So that's, and that makes sense because I had nitric acid to begin with, and so these H pluses would be in water because of the nitric acid I added. If you can do this one, this is the hardest it would ever be, ever, okay, for you guys. So, and it does get a lot easier from that. I just wanted to be able to show an example of a really hard one. The worksheet ones won't all look like that. Maybe there'll be like 1 that will, or 2 or something look like that. I believe if I remember the worksheet right, actually there's 3, and they have stars next to them, and those are extra credit. Okay, so that's electrochemistry in a nutshell.
The end.